Okay. So today we are going to have a online session on container security with Twistlock. So here I have Ian from the Twistlock team, and he'll be giving us brief about Twistlock and some standards on container security as well. We'll be having a Q&A session at the end, so the attendees joined in via Hangout can speak to Ian directly. Others can paste their questions on the YouTube chat and or on the meetup group as well, and I'll moderate those to Ian. Ian, you can start now.
Okay, thank you.
Yeah, thanks.
Hi everybody, my name is Ian and I am a product manager at Twistlock. Thanks for joining today on Saturday. I know it's early over there. For my presentation today, I'll talk about Twistlock and our take and approach on container security. And I realize that not everyone there is necessarily interested in a vendor solution, but interested in security in general, how it works and what you need to be concerned about for containers. So a lot of what I present today is going to be, I think, good general security container practices within the context of what Twistlock does. What we do is we automate a lot of the security components for our end customers. But when you're getting started, I think it's good to go back to first principles. What we do is we automate a lot of the security components for our. Rati, I'm seeming to get a little bit of feedback for some strange reason.
Is it fine now?
It's fine now. I heard someone else talking. I thought someone was asking me a question, but it was just me recording me some feedback. Okay, so let me continue. What I present today, there's a lot that you can derive. You can fall back to first principles and take a look at how we've broken things down. So Twistlock, just as by way of quick introduction, we are a cloud-native cybersecurity solution. And I know that sounds a little bit generic, but really what that means is that there is a new way of architecting software and deploying it. And in many ways, it solves a lot of problems and makes the maintenance and deployment of software much quicker. It makes it possible for us to make changes to the way that things work, add new customer features or fix bugs, and push that up into production fairly quickly. And so cloud native cloud native computing is really oriented around containers and orchestrators and cloud providers. And so what I mean by cloud native cybersecurity is what we've tried to do is fit within those new workflows. There are a lot of security solutions out there right now, and what I call quote unquote legacy. They might not be happy to be called that. And they've built solutions around the way software used to be architected, sort of like big monolithic applications, where when development was completed, you would throw it over the fence to your operations team, and then your operations team would allocate some window of time sometime in the future in order to take your software, understand it, deploy it, test its operation, and then really put it into full production. And well, that doesn't really fit within what the goals of cloud native computing is, which is to be much more agile. And so we've built tools and solutions to enable and to work with and aligned with these new principles. On the right here, I just have a couple of pictures of the big players in terms of cloud native computing. And what you guys have probably seen either in your professional work or as you've been following along is that there have been a lot of changes in terms of what cloud native computing is considered to be, how it works, and who the major players are. And when I first started working with Twistlock over 2.5 years ago, Kubernetes was just sort of an emerging component. And today, in terms of a deployment, you can't really deliver a real working production grade application without some type of orchestrator. And most of the time, you'll pick Kubernetes. Also, what's changed is sort of like what the underlying runtime is for what your container runtime is. And Kubernetes has made the first sort of big push into implementing CRI, this container runtime interface, which has opened up a lot of other types of container runtimes which are possible within those ecosystem. And so a lot of what we do within Twistlock is also ensuring that we can deploy seamlessly in all these different types of environments. So support for Kubernetes, for Docker Swarm, for DCOS, OpenShift, and then Docker and Dockerless types of environments. So there's a lot of things that are changing, and this space is pretty exciting. And that's probably why you guys have 3,500 members in your meetup group. I talked about what we do, Twistlock, as a commercial provider. I'll give you a demonstration of what that is later. But there's lots of interesting and useful tools out there if you're exploring security for yourself. The reason I have this slide here, besides this ecosystem leader thing, is in the center there is in the United States, there is a government body called the National Institute of Standards and Technology, and they have a number of publications that are oriented around security. And our CTO was one of the lead authors for something called NIST Special Publications 800-190. And this was a collaboration amongst a number of thought leaders in the security space, and also, I mean, many of the other folks within this realm of security also contributed in terms of feedback. This one's interesting because it will dive into sort of all the threat and attack models that are currently known in this container ecosystem. And so it's a good read. It's about 90 pages long. It describes, again, what I said, some of the threats, the attack vectors, and then also some of the things that you can do to remediate and mitigate these types of attacks. And so in terms of what Twistlock does is we actually address many of the attack vectors described there. We provide countermeasures for those. So companies tend to come to us in general because they're interested in just basic, what I would call security hygiene. There's a lot of things that you can do just to secure your environment that aren't complicated, that don't require complicated configurations and don't require complex configurations and a lot of computing resources or specialized software. And that can be around vulnerability management and compliance. And so for vulnerability management, you are looking inside your containers, your images, your host, sort of all your infrastructure to identify if there's vulnerabilities that you need to be concerned about. And so, there are a number of open source databases out there. Each of the operating system vendors also have their own databases. And there's also commercial databases. There's databases for application-specific frameworks, such as Python, Node.js, Java, etc. And those describe packages that you have built into your container, or you've provided on your host, and what associated issues there are with them. And so one of the things that Twistlock does is that we do vulnerability scanning across the lifecycle of an image or a container in your ecosystem. And we start doing our scanning for vulnerabilities in the build phase. So the security team can set up policies that become a quote unquote quality gate that must be passed before a container image that's being built in your build pipeline can be promoted into, for example, your test environment or into your production environment. Another thing that we do is we also assess all your hosts your images and your containers against a set of compliance checks. And we have built our compliance checks around a benchmark from the from the Center for Internet Security, who publishes a CIS Docker benchmark, a Kubernetes benchmark, and actually a ton of other benchmarks. What's interesting about this is also something that you can look into by yourself. You can download their document and you can see what they consider to be best practices for configuring your Docker daemon, for building your images, for running your containers. Also, there's one for Kubernetes that we operationalize and that we incorporate as part of our product. And that tells you another bunch of things about the best way to configure your API server for your Kubernetes deployment, the best way to configure your worker nodes or your master nodes. We also offer we also take the general Linux benchmark. This is something that we just started to offer in the latest release of our software. And that describes the best way to configure your host operating system. And what's important about these benchmarks, what's important about these benchmarks is that it gives you a way to ensure that everyone is building something according to the same standard. So what has been defined as a best practice, it's possible to validate that through these checks. And I just saw an interesting security bulletin just the other day where a sales guy working for AWS posted a quotation about a deployment that he was talking about with GoDaddy, his customer. And it was a detailed spreadsheet that described what the deployment was going to look like, how many machines were in this deployment, what each machine was doing, sort of like the dimensions of those machines. And that type of information can be utilized by an attacker in sort of many different ways. So for example, if an attacker is trying to figure out, how is this system architected and where is the best place for me to start my attack? Where, for example, are the high value assets in this deployment? Any type of information that describes what your system looks like becomes a stepping stone for an attacker. And if you were to have a compliance system in place, it would prevent, sort of like a non-technical salesperson who understands how S3 buckets work, but doesn't really understand the security implications of what he's done by making this bucket public or publicly available. And I think that's kind of what we have going on today in this new paradigm with cloud native computing, which is we're pushing more responsibility to the developers who already have a lot of responsibility to push their software up to meet requirements in terms of capabilities and functions. Now we also expect them to understand what the best practices for security are. And I guess what I would say is that security as a topic by itself is just a dense, deep issue, which takes several years of studying to become really proficient. What these compliance checks do is let the developer work and build his software, and then assess what he's done and the decisions that he thought were the best decisions against what a company and what a third party believes to be the best practices for deploying a container. And so an example of a simple compliance check that comes from the Docker benchmark is, do not configure your image to run as root, right? By default, if you were to write a Docker file, just a simple Docker file, and generate an image and run it, when you run it, it's going to run as a root user. And this type of compliance check, whether you're reading the document and running the checks that is described there manually, or whether you have Twistlock constantly assessing these checks across your ecosystem, that's going to raise a red flag. And if you and your security team decide that that's a bad practice, it's actually considered it's got a rank of a critical score in terms of what type of security violation that is, then you can take action on that. And then we have, so moving forward from compliance, where I spent a lot of time already, then we have a couple of other solutions around cloud native firewalling, right? So networking for containers is different than the networking that we've seen 10 years ago. You know, it's software defined networking, and then, you know, there's overlay networks, and a lot of this can be black boxes in terms of legacy security tools. And Twistlock provides a layer 3 and layer 7 firewall, which I'll show you in the demonstration a little later. And then finally, runtime defense. It's in terms of security, simply just moving your application from the way that it runs right now into a container will actually make it more secure. And the reason is because the whole notion of containers is it segregates what's operating inside the container away from the host operating system using namespaces and C groups. So just doing that by itself potentially makes your application more secure. Of course, I mean, there's ways to start your container that can unwind those benefits. Like, for example, you could start a container in privileged mode. That's something that your compliance check or our compliance checks should alert on immediately. But there's certainly ways to undo that. But just in general, moving your application to container makes it more secure. But there's also other things that you can do that Twistlock does. Because containers and images are immutable, and because they run that way, it's possible for you to predict what it is that a container will be doing when it starts to run. Because containers, when they start and they stop, they are architected to be immutable. And so what I mean by that is, for example, if you have a simple Node.js application running inside a container, if it starts up, just by inspecting the Docker file and then inspecting the container after it starts to run for a period of time, you can determine what processes should run under the course of normal operation. You can tell where that container is writing in the file system during the normal course of operation. It might simply write to a log file. You can tell where it's listening on the network or where it's writing to the network. In this case, your Node.js application might be just listening on port 80. And then from these observations and from what you know about the way that this image is instantiated, it's possible to create a whitelist security model and say that this container along these dimensions, processes, network, file system calls, does this. And anything that falls outside of this particular model is an anomaly. It's something that the security team should investigate. So these are sort of the 4 areas. I've got 5 lines here. One of the things that we originally did in an early release for Twistlock was role-based access control. And well, as the ecosystem has evolved, it's been determined really that role-based access control is something that is better served when it's done by an orchestrator. And so Kubernetes, for example, now has a rich set of tools and systems in order to enable role-based access control for the Kubernetes cluster. And so this is something that customers come to us less and less, but which they actually came to us early on in our release. And that's just a testament to the way this ecosystem moves so quickly. Okay, so just a quick picture to orient us for the demonstration about what I have to show today. This is sort of like a big picture of our architecture. On the left here, we have an intelligence stream, and that's essentially an aggregation of a number of open source and closed source threat feeds. And these threat feeds contain information about, for example, vulnerabilities in base OS layers, in the application framework layers. But we also work with commercial suppliers such as Proofpoint and Exodus. And these companies give us valuable data about MD5 checksums for things like viruses and malware. Exodus, for example, gives us information about zero-day vulnerabilities such that we'll be able to alert our customers on issues that may not.
Ian, can you zoom in into the PPT? Can you make it full screen?
Yeah, sure. Hang on.
Yeah.
Hit play. How's that?
I don't think it's visible on my screen yet. It's still small.
Okay, I think it's coming. Just let me know when you can see it.
Okay.
So that's our aggregation of our threat feed. For here, you can see that we have a number of suppliers for Linux-based threat feeds. And the reason we do that is to be able to provide the right contextual information for the right image in your environment. And so, some images that you're building or that you are utilizing from, say, a third-party supplier, or that your colleague has decided is a better fit for his microservice, that means that those containers or those images can have different base OSs. My container might be based on Alpine because I'm optimizing for size, and your container might be based on Ubuntu because you actually need a fuller-fledged operating system.
Ian, your screen has gone blank actually.
It's on blank?
Yeah.
Okay.
Can you just zoom in? Can you? I don't think it's going on the play mode. Can you just increase the zoom?
Okay. How's that?
Yeah, I think that should be better. Yeah.
Okay.
Yeah.
Sounds good. So yeah, the point of having all these different streams is that we can provide better contextual information for the image under assessment. And so, if my container is based on Alpine, I'm going to get vulnerability information based on Alpine. So based on what Alpine believes the severity of that vulnerability to be within the context of its operating environment. And if my colleague is building his base OS based on Ubuntu, then we're going to get Ubuntu vulnerabilities and the way that Ubuntu assesses its vulnerabilities according to its operating environment. So Console is our central component. We deliver our software to our customers as containers as well, and that makes it easy for customers to deploy into their environment. I'm not sure how much information you guys want about these other integration points. The other key bit here is Defender. So Defender is our security agent. It runs one per host in our customer's environment, and it's this is the component that actually observes what's going on in the running containers in your environment, and then takes action based on the policies that you've set in Console. So for example, in Console, you might want to set up a policy that says, prevent any container that's got a critical vulnerability from running in my ecosystem. And this Defender container would actually would be the component that enforces that. So a lot of customers ask us, does Defender run as a privileged container? Well, we're actually trying to architect our software to be as secure as possible. And so we're only taking privileges that we actually need. So for you guys that are familiar with some of the command line options, for example, you can run a container with -- privileged, right? And -- privileged automatically bestows upon that container all possible kernel capabilities, and it also removes any C group restrictions. And so essentially, a container like that, it can do anything that a root user would be able to do on their host, assuming that container was also started as root. In this case, Defender, what we're doing is just taking a couple of privileges, and we're not actually removing any C group restrictions. The final bit here has to do with what I had talked about Twistlock being architected for cloud native computing. What we have and what we offer is a scanning component, which runs as a plugin for Jenkins. And if you're not using Jenkins, we also have a command line operation, a command line tool called Twist CLI. And what's important about this is that it gives the security team some visibility and some way to inject security policy into the artifacts that come out from the development team. And so, for example, your security team and your DevOps team might decide that compliance checks X, Y, D, and F are all important for their organization. And they can enable those particular checks. They can also say that any vulnerability that is got a critical rating and that has a fix available from the vendor should fail this build pipeline. And if all the checks and all the criteria set up by the policy here in Console pass, then the build is allowed to proceed. And that's just, that's a nice way for developers to quickly see if what they've built actually complies to what security requires, and they can iterate towards something better. So are there any questions there? If there are, then I can answer them now. Otherwise, we can hop into a quick demo.
Ian, you can continue with the demo. We'll have Q&A at the end. Thanks.
Sure. Okay. Hang on. Can you see that?
Yeah, I can see that. Just give it a minute for it to reflect on the YouTube as well. Yeah, you can continue now.
Okay, good. So this is one of the key entry points into the console dashboard. And what this is doing is it's giving a overall picture of what the deployment looks like in this environment. I've got, what I'm displaying here are all the Kubernetes system components, which are not important. I'm going to hide them right here. And then what I've deployed here is the sock shop. So I'll zoom into it.
Hey, hi, Ian. Sorry, but I can see the Stack Overflow window instead of some. I think.
Yeah.
Yeah.
This is what I was looking at what the privilege flag means before. Hang on, let me shut this down. Okay, how's that?
I don't see any screen here.
Okay, let me start again. I'll stop this share.
Okay.
Okay. I think it'll work this time. How does this look? I'll just take a second to come up.
Yeah, I can see monitor/firewalls. So.
Okay, good.
Yeah, that is this one. Yeah. Just give it a few minutes. Yeah, it's on the YouTube as well. Yeah, you can continue.
Okay, good. So I'll start again. This is the entry point to our dashboard, and it shows a bird's eye view of all the deployments within your environment. And what I have in my environment is a Kubernetes cluster, one master, and 2 nodes. By default, we hide the Kubernetes system components, so I'll do that now. And what I've got deployed is the sock shop application. And the sock shop application is just it's an example Kubernetes application. It's just simply a website that sells socks. So it's got a front end, a middle tier, and a back end tier. And I can drill into it. And what we've done as part of Twistlock is we have automatically mapped out what this deployment looks like. And so I think one of the things I touched on before, but which I'll repeat right now, is that with containers and with these cloud native applications, what this new infrastructure enables is a lot of rapid change. And what the antithesis is to rapid change is good security. Essentially, every time you make a change to the way that your software operates, you should, as a best practice, which we all rarely have time for, but what you should do is reassess what those changes mean against what your security policy is. And so, when you can deploy software multiple times per day, or maybe several times per week, or definitely a few times per month, I mean that whole keeping track of what the changes are and assessing it against securities is not really a task that you can do reliably all the time. There's simply not enough time and not enough resources. And so one of the key tenets for Twistlock is to automate as much as possible. And what is it that we automate? It's actually the maintenance and the generation of the rules of what's allowed and what's not allowed. What I talked about before was our runtime defense and the ability to model what a container is doing based on an inspection of how the container is constructed, indirectly through its Docker file, and then also for some limited learning period of time for what it's actually doing, and then locking that down in terms of a whitelist security model. And this is part of that whole story is shown here in this radar, because what we're doing is we are looking and assessing and seeing how each of these containers are talking to each other. So you can see, for example, I've got this front end. It's talking to carts over port 80, and then carts is talking to MongoDB on port 27017. What's not possible to do with this model lockdown is for front end to try to talk to Mongo latest directly. And by nature of the models that we've created for these containers, we'll automatically block that action. So what's possible for folks that are familiar with Kubernetes, what you'll know is that Kubernetes has this system called network policy. And network policy is a YAML file that will allow you to define how containers are allowed to talk to each other when they're operating as an application. And originally what we had done in part of this radar is we showed you what this mapping was, and then we had an export button up here that exported the network policy, and that would allow you to import that network policy into your system. Well, now we just automatically lock down this network policy for you. And that's part of one of the key parts of the automation that Twistlock offers. So for example, if you decide, for example, in your next release that it's inefficient for front end to talk to carts and that it should be talking directly to Mongo latest, and you eliminate this component, we'll automatically map that out. And so we'll have two versions of your application, one where front end talks to carts, and then a separate set of models where front end talks directly to Mongo latest. So there's no manual rules that you need to configure to reflect that new reality. Also, you can see that it's possible to click on each one of these nodes to get some more information about its compliance level and some of the vulnerabilities that are in these components. So by default, you should see all green and orange and yellow pods. And what that means is that green means is that you've got no vulnerabilities or compliance issues. Yellow means you've got just low severity vulnerabilities and compliance issues. Orange means that you've got just medium level vulnerabilities, but red and purple mean you've got critical severity vulnerabilities in these images, and they're probably something that you should consider addressing. And whether that means that you have investigated that vulnerability and decided that it's not really such a critical issue for your environment, or two, that it is, that it should be addressed, it gives you the ability to make those decisions. part of what we've done, and I'll dive into this compliance section in a second, is we have ranked these compliance issues for our customers. So you can see that we've got critical level vulnerabilities, high, medium, and low. So when you go through the Docker CIS, basically what you'll see is scored and not scored checks. Not scored checks means that it's actually it's something that it's difficult to implement without understanding some explicit detail about a configuration in your environment, and it varies from customer to customer to organization. But the vast majority of the checks in these environments are scored, in excess of 95%. But it makes it difficult for people trying to get started quickly to understand which ones are actually really, like, of all the compliance checks, which ones should you address first. And so our security research team has ranked those checks, and then when you look at what checks you have in your environment, you'll know which ones are important. So for example, let's dig into, I thought I saw one interesting one before here. Here, container app is running with weak settings. So click into that to see exactly what that means. So my carts database is one of the containers that has that particular issue. If I click onto that, container app is running with weak settings. You can see that the startup command for MongoDB in this container is it should be running with the --auth and require SSL commands in order to better secure it, as an example. You can see, for example, this container also is running with the seccomp profile disabled. So I'm not sure if you guys are familiar with seccomp or not, but basically Docker has done a lot of work to define a seccomp profile, which basically defines a set of system calls that are allowed to be used by an entity, such that it's flexible enough that everyone can use it in general, but it locks down some system calls that would never be used, should never really in general be used. So there's no way that there's actually no good reason to disable it. It should be enabled in general, and that's an example of a compliance check that we check against all running images and containers in your environment. So this is just an example of say, a developer trying to get his job done, and has discovered that one way in order to make his application work is potentially to disable the seccomp profile. And so what that gives the security team and the DevOps team is an opportunity to try to assess why that decision was made, and if it really is the correct decision or not, or if there's a better way of enabling this developer's application to run. So I hopped from here to compliance, but I also wanted to show one additional thing here, is that so we have this layer 3 firewall, right? And this layer 3 firewall, for example, would prevent a number of types of attacks. For example, an attacker breaching your front end, which is sort of like the best way to breach your application. And then, for example, maybe trying to do a port scan. And in a port scan, the attacker is just trying to understand, just trying to orient himself within your environment. Like, what are all the other assets that I can reach? And can I find another vulnerable asset in this environment that will help me get to actually the highest value asset in this environment? And so this network policy, for example, which says that front end can only talk on port 80 to cart, to catalog, and to user, means that suddenly if Twistlock Defender detects that this port tried port 2, port 3, port 4, port 5, obviously it's a sequence of network connections that indicate a port scan, we can alert on that. And that gives your operations team an opportunity to figure out, well, who is in here and why are they in here and what are they doing? We've also got a layer 3 firewall and a layer 7 web application firewall, and that protects your front end. So what you can see from this network diagram is that there's no IP addresses actually, and what we've got with this cloud native computing and with multi-node applications running as microservices within an orchestrator is that IP addresses really don't matter. Your front end container can be running anywhere in the cluster. It can be shut down at any moment in time and replaced with a newer version, or it might fail and the orchestrator might recognize it's failed and restart it on a different node. And so we offer this layer 3 firewall layer 7 firewall, and technology for layer 7 firewalls is pretty mature. I mean, everyone knows what it is that they need to do. The real innovation here from Twistlock is the ability to specify within your configuration. Let me show it to you. That a layer 7 firewall should be connected to my front end anywhere that it exists in the environment. And sorry, this rule already exists, so I'll just hit cancel and I'll go back to here.
Ian?
Yes?
We're kind of running out of time now. We just
okay. Yeah, there's a lot to talk about, and where would you like to go now from this point in time?
Maybe you can just cover up any important points that you might have, like just a recap or any closing points, and then we can just move on to questions quickly.
Okay, yeah, sure. So I think that my big summary is that in general, customers come to us to talk to us first about basic hygiene issues, including vulnerability management, so scanning and looking for issues, and then also compliance issues. And we have reports for that here. I can just show that to you quickly. So here's your vulnerabilities. I can click into each one of my images. You can see how they're ranked, and it shows me a bunch of issues. So for example, in this particular container, I'm running this package. It's got this CVE, and hey, it's got this fix in version. It's addressed in version 1.2.0. So the compliance reports look the same. What's more advanced and customers are starting to adopt is this runtime protection. So for example, let me look at. Let me find. This. I told you before that what Twistlock can do is it can understand what a container is supposed to be doing by a combination of inspection and machine learning. So if I were to look at this container image from Mongo, you can see that we know that these particular processes should run in a normal container. In the way that this container is operating in the current environment, we know that the only thing that it should be doing in terms of network is listening on port 27017. And that in terms of file system, it's writing to the directory DataDB. So this is the model that we've locked down. And when we observe, or when Defender observes anything that's different than that, then we can alert and provide some more information to your operations team. And what's important about this is that this activity, this creation of what these rules are, happen automatically. And so when you re-architect your application, or when you do a fix, or when it changes slightly, we automatically create a new model for each unique image in your environment. So if, for example, your old application plus your new application are running simultaneously, we'll have a model for your old application and a model for your new application. We'll automatically determine what these rules are. Previously, and in legacy type security applications, you would have to sit down, your developer would have to sit down with your security guy and describe to the security guy exactly how it works. And then the security guy would write a bunch of rules that reflect what that application is allowed to do, and then conversely, what it's not allowed to do. And with the way that containers are developed and the way that they change so quickly, that's really not feasible anymore. And so this is the subsystem that handles that for you. So that's it. There's a lot of other things that we can dive into, but I think we could probably dive into that in the question and answer section for whatever's interesting to you. Thanks very much.
Yeah. Thanks, Ian. That was a really wonderful session. So in the Hangouts, if anyone has any questions, they can ask it on the chat or in person. We have one question though. Can we have the percentage acceptance based on severity of vulnerability? Did you get that?
Is it in the Hangouts?
Yep.
Hold on, let me look. Hello, can you please, can we have the percentage acceptance based on, can you clarify your question? I'm not sure I completely understand it.
Yeah, I mean, I think the question means is that if can we have a percentage of acceptance, that is, you know, if this vulnerability is if this image passes 50% of the test cases or the audit requirements, will it pass, or do we have any percentage acceptance in Twistlock?
So not percentage, because I think that that particular metric wouldn't make sense, because then it would allow some potentially really bad things to get through. What it is possible to set your thresholds on, it's possible to set up, in particular for the vulnerabilities, thresholds. And so every vulnerability with our environment is normalized to low, medium, high, and critical. And so, for example, what you could do is you could set your threshold to critical to weed out just, you know, sort of like what the general security community what the general community considers to be the worst. So let me actually show this to you for 1 second, because it might help to clarify about maybe a good way to set up what your thresholds are. So what we have here is this thing called Vulnerability Explorer. And what it does is we have this top 10 list. And this top 10 list looks at all the vulnerabilities in your environment and then surfaces the ones that are the worst based on the way that they're deployed. So let me click on to this one, for example. Here's why this vulnerability is so terrible. One is that the attack complexity is low. The attack vector is over the network, and this thing is connected on the network. An exploit exists. And what does that mean? For example, there is a website called Metasploit and a bunch of other websites that show non-sophisticated users exactly how to exploit a specific vulnerability. And so this one, CVE 2018-1123, has an exploit that a non-sophisticated attacker could use on your environment. Not only that, but this container in particular is running as root, and on top of that, it has a fix. So, you know, this is one that can be addressed immediately. I think that setting a percentage level is probably not the best way to addressing issues as something is going through development, but setting these thresholds based on severity level is something that we offer.
Ian, another concern, the issue that we face is we almost have a denial of service attack on the containers. We always face the threat of that attack. So how do you guys scan it or avoid it or prevent it or alert it? I mean, do you guys do anything regarding that?
Denial of service is, let me look. Yeah, denial of service, I think would be a better fit for like one of the border appliances that you deploy as part of your cloud infrastructure. So, for example, a border appliance that you apply to protect your overall Kubernetes cluster environment.
Okay.
Outside the scope of Twistlock.
Oh, okay. Do you guys also report if there is any unauthorized access to any file?
Yeah. So for example, let me show you this. This is our Incident Explorer. And part of what we're trying to do is, like, you can see that we've got a whole host of audits here. We've got some host audits. You know, you can configure Twistlock to kick out information to syslog, and that information can be ingested by your monitoring tool. But what we're doing with Incident Explorer is we are detecting unique patterns that detect an attack. One of the things that we have as part of our runtime model, or one of the dimensions that we continually monitor, is the file system. And so when there is a write within a container file system, if it's a write to an unexpected path, something that we haven't noticed in our behavioral learning phase, we can alert on that. And this incident is interesting. So we've captured a couple of incidents which indicate that someone is trying to set up a backdoor SSH access. And so I look at this file system event, and I can see that someone tried to write something to the .ssh directory, a key to the .ssh directory, which would then enable them persistent access to this particular container over SSH. So yeah, it's something that we can detect and we actively alert on. Does that answer your question?
Yep. Just a last question as we are running out of time. How do you add any new vulnerability definition check? How do we add any new checks in Twistlock?
Okay, so there's a couple of different things that you can do. You can here is our vulnerability rule, and you can specify, for example, alert on all OS components. Let's see, where is it? So all OS packages that have a severity of critical or higher, say for example, block the deployment of any of those containers. It's possible for you to specify specific CVE actions. So for example, CVE 2018-12345 may have no fix currently available from the vendor today. So then you could say, for example, 2018. Sorry, there's something wrong with my browser. Ignore all of these particular CVEs across my system, as an example. If you want, you can also define your own vulnerability. So for example, we're reporting on open source components in terms of vulnerabilities, also some closed source components if you're doing Windows containers. But within your organization, you may have your own set of packages and applications that you package up as libraries or whatever. You can also augment our threat feed with your own threat information. So for example, you might say that internal lib 1.0 and less is a vulnerable component, and within this rule, alert on that. Does that make sense?
Yep.
Okay. Did it answer your question?
Yes. I think that answers. Okay. Just one last question. The Defender container, does it run in the privileged mode on all the containers and pods to interact with the console?
No, so it does not run in privileged mode, but we do take a couple of kernel capabilities. And those kernel capabilities are, like, for example, ptrace. What is the other one? Ptrace, some networking capabilities, so 4 in total. And the reason that is because we need those capabilities in order to be able to understand what's going on, to have visibility into what processes are running inside a container, where it's making it file system writes, where it's communicating on the network. But we're only taking 4. I think how many kernel capabilities are there in total? Is it like 17? So yeah, we're taking 4 out of the 17.
Okay, that sounds good. Ian, I think we will need another session from you.
Well, I'm happy to do it. Yeah, I'm happy to do it. Thanks for having me.
Yeah, a little longer session the next time. I will be sharing contact how to contact Ian or reach out to him. If you have any questions, you can reach out to me. I'll make sure that I'll get it answered from Ian as well. Thank you, Ian, for taking the time and sharing your knowledge about Twistlock with us. This was really informational, knowledgeable, and thank you to all the attendees taking their time out on a Saturday morning. And we will be having another session on container security with Twistlock. Maybe we'll plan it in the upcoming months, and I'll be sharing all the details regarding the slides and the Twistlock website and the documentation and the contact details as well.
Yeah, sounds good. You know,
Yeah.
maybe what we can do next time is you guys could provide some questions or things that are interesting to you up front. I can prepare for a presentation based on that.
Yeah.
This one's like an interesting overview, but yeah, maybe something more detailed and more customized to what you're interested in hearing about.
Sure, Ian. I think that is a great idea. I'll work on that. And
Okay.
thank you so much once again. Thank you,
Yeah,
Ian.
thanks, guys. Thanks for having me.
Yeah.
Have a nice day.
Thank you. Yeah.